Hello. This video will demonstrate how to find the roots of a complex number. All right. Once again, we need to take our complex number and convert it to polar form. Hopefully, this exponent tells you we're looking for a root. So just to reiterate, if you have, let's say, the fifth root of 12, how I can write that in exponential form is that. Okay, so I'm taking the fifth root. So again, the first step is to convert, if you are given complex form, convert to polar form. Again, on your calculator, that should take about 10 seconds, right? We have seen that we have n equals 0, n equals 1, n equals 2, and so on. Remember, in this case, let's say, for instance, we're taking the fifth root. There are going to be 5 roots, so I have to do 5 things. You're always going to start with n equals 0. So in this case, we'll say n equals 0, n equals 1, n equals 2, n equals 3, and n equals 4. If I'm just finding the cube root, n equals 0, n equals 1, and n equals 2. If I'm taking the 11th root, n equals 0, n equals 1, n equals 2, all the way to n equals 10. Okay? So, for each value of n, the majority of this formula remains the same. The only thing that is different is that this value of n changes from here to here. Okay? In other words, all we're really doing from n equals 0 to n equals 1 is we're adding 360. And from n equals 1 to n equals 2, we're just adding another 360. So once you get a feel of what this formula is doing, it should not be difficult to work with. Okay? Let's do an example and see how it works. So suppose I'm trying to find the fifth root of 10 plus 5i. Remember, the first thing that we need to do is convert 10 plus 5i to polar form. Again, using my calculator, I find that 10 plus 5i in polar form, the modulus is 5 square root 5, and our argument is approximately 26.565 degrees. Again, when we're dealing with trig, you really need to be careful about not rounding just to one decimal place. The reason I personally am going to 3 decimal places is because I have 5650. Okay? If I did 57, I'm going to be a little inaccurate. Again, you have a calculator, so it should not be difficult to go to 2 or 3 or even 4 decimal places. Okay? So again, I converted 10 plus 5i to polar. I changed it from root form to exponential form. No problem. So if I want to find the first root when n equals 0, okay, if we're going to write all of this out, I want to find the fifth root of 5 root 5, all right, times the cosine of our theta plus 360 times n. All right? Divide by, and don't forget this part, divide by the root, right? We want to take the fifth root. Now, do you have to write this out for every single value of n? I think it's a good idea to do it for n equals 0, so the grader, me, or whoever else is grading this, knows that you know what you're doing. Okay? If we want to then use our calculator to figure all of this out in complex form, remember, we put our modulus, angle sign, right, parentheses, theta, divide by 5. When n equals 0, that's all you have to do, right? This is 0, 26.565 divided by 5. And when you do that, you should get approximately 1.61 plus 0.15i. Right, so this is our first root, which we get when n is equal to 0. All right. Now, to find n, what happens when n equals 1 and 2 and 3, this is nice and easy. Just use your calculator, right? The first part remains the same. 5 root 5 to the 1/5 power. My angle, again, let's go back to this. We mentioned it before. The only difference from n equals 0 to n equals 1, we are simply adding 360. So I'm going to take my angle here, my theta, just add 360. And I'm still dividing by 5. And when we do that, we get 0.356 plus 1.58i. Okay? And I'll just do it together. When n is equal to 2, again, this piece remains the same. 5 root 5 to the 1/5. The only difference, we add 360 to this. And if we add 360, we get what? 746.565 divided by 5. And that gives us approximately negative 1.39 plus 0.83i. All right. So what I have done here is continued for n equals 3 and n equals 4. Therefore, the fifth roots of 10 plus 5i, don't forget what our original question was, right? The fifth root of 10 plus 5i are these 5 roots here. And we've seen in class that if we plot each of these points on a polar graph, again, hopefully you're realizing what this radius is. What is this radius? This radius is the fifth root of 5 radical 5, which is approximately 1.62, right? 0.5, 1, 1.5, 1.6, 1.62. Notice that these 5 points are evenly spaced out. You should easily be able to tell me the angle difference for each of these. And I hope that makes sense, right? 60 divided by 5 is 72 degrees. So again, if this angle here was 26.565 degrees, this angle here, then this angle here is 26.565, adding another 72 degrees, adding another 72, adding another 72, adding another 72, and so on. Okay? To me, I think it's important that you see the geometric representation of the fifth roots, or any roots, of a particular complex number. This will help us as we try to understand the nth roots of unity. So when we're thinking about unity, we should be thinking about the number 1. All right? All right? Or 1 plus 0i. Okay? If we're going to look at this as that and that as that. Okay? So let's think about what this means if I was going to convert this to polar. I can see that my radius will be 1, right? 1 squared plus 0 squared is 1. Square root is 1. Okay? The angle of rotation is 0 degrees. Okay? So this point here on the imaginary graph, 1 plus 0I, translates in polar form to 1 times cosine of 0 plus I sine 0. Remember, if we're looking for the roots of a complex number, they will be evenly spaced out. And in this case, I know that my radius will always be 1. So let's look at that. Let's look at an example. So suppose we're going to take the fifth roots of unity. Again, I'm doing this the long way, and you're going to realize there's a much easier way to do this. Again, using our formula, n is 0 for our first root. I'm taking 1 to the 1/5, which you already know this piece is 1. Okay? 0 plus 0 divided by 5 is still 0. Right? And same. So what you'll notice, 1 is always one of the roots of unity. Okay? For n equals 0, we get a root of 1. Always, always, always. What I'd like you to think about with regards to the fifth root, right, for n equals 1, really all that is, the modulus is going to be 1 no matter what. And all we're doing is we're adding 72. Do you know how I'm getting 72? I very much hope you know where I'm getting 72. Fifth roots, 360 divided by 5 gives us 72 degrees. So if the roots are evenly spaced about this circle with radius 1, they are 72 degrees apart. So what you should find is, okay, I've finished this here. I've done this for n equals 2, 3, and 4. Used my calculator, just adding 72 degrees to each angle. I've plotted my complex points. Again, you can see they are evenly spaced with 72 degrees between them. Unity should be easy. Your modulus will always be 1. Your original theta will always be 0. And finding the amount of increase, simply take 360, divide by how many roots you want. Okay, well, I hope that helps. Thanks for watching.